Hi, this is Barry Molitor, and this is my explanation of Newton's method and the key ideas behind Newton's method for the solution of systems of nonlinear algebraic equations. And the way Newton's method works is, if you consider, I've drawn here a function, and x here is the root. And let's say, well, in Newton's method, we have to make an initial approximation or guess. Let's call this A. And what we do here with our initial approximation is we calculate the derivative at A, and we get our tangent line, which is our derivative. And then when we calculate that back to the x-axis, we get our first approximation to the root, and then what we'll do is repeat so we get our new location, and then once we calculate the derivative of that, we get another tangent line and a new approximation, and every time we do that we get closer to the root. And what we see here is really that f of x is approximately equal to f of a plus the derivative of a times x minus a. And we're looking for, we're setting that to 0. So what we have here is 0 is approximately equal to f of a plus f prime of a x minus a. So when we work that out further, we get x minus a equals negative f of a over f prime a, such that x equals approximately equal to a minus f of a over f prime a. And this is the, once you get an approximation, you plug it back in to get a better one. And what this really is, this is a linear approximation of f at a for vectors and vector valued functions. Now, there are some limitations to the Newton method. You have to, number one, have a good guess, a reasonable approximation. But there are other times when you might have a strange looking function that does this kind of behavior. And if your initial guess is here, you're picking a function, you're at a point in the function where the derivative is horizontal. And so that's going to become a problem. And then other times, if you start here and you use this as an approximation, you're going to come over here, and then you're going to do an approximation, and it's just going to give you strange answers. So what you need here for Newton's method to work, you also need a smooth function. So there are pitfalls, but Newton's method is a very accurate way and to solve nonlinear equation systems, and also iterates to an accurate answer quickly. And it also does that with linear approximations for vectors and vector valued functions.